Hello everyone, how are you all? So Kathy is knocking just round the corner. It's the best time to revise all the concepts that you have gone through. And that's why Catway has come up with the concept, a revision of all the concepts on circle. And within the next 10 minutes, I'll let you guys go through all the concepts that are there in circle, be it from circle to cyclic quadrilateral to Ptolemy's theorem. We'll be revising all the concepts, and that will be sufficient for you if you'll be practicing around 3-4 questions on each concepts. So let's start with circles. So here is the topic is circles. Okay. So the first concept is this is your circle, right? The circumference is 2 pi r. Circumference equals to 2 pi r, and the area of circle is pi r square, right? And if we'll be considering any arc, if this angle will be given theta, so area of this arc will become theta upon 360 into pi r square. And similarly, circumference will be equals to theta upon 2 pi r into theta into 2 pi theta upon 360 into 2 pi r, right? So these are the four basic concepts that are generally there in circles. Now there are 10 or 12 theorems in circles. So first theorem is that if you draw any perpendicular on a chord, let's say this is a chord AB. Okay. If you are drawing any perpendicular on this chord, let's say this is PQ, where P is the center and PQ is perpendicular to AB, then AQ equals to AB. That simply means that PQ is bisecting this chord in two equal halves. We can say it in that form. Let's say this is radius, this will also be radius, this side is common. So if AQ will be equals to QB, we can say that APQ and AQB are congruent by SSS criteria, right? So let's say I'm giving you a question. The question is that let's say there is a circle. Okay, this is a chord. Let's say this PQ is a chord, and this is another chord. Let's say this is the center O. There is another chord. Let's say this is 3 centimeter in length. This is 3 centimeter in length. Okay, I'm giving you OU equals to 3. This is S. This is T. This is U, and this is R. I am giving you OU equals to 3 centimeter, OR equals to 3 centimeter, PQ equals to 8 centimeter, OT equals to what? Now see, if PQ equals to 8 centimeter is given, and I have said that these are perpendicular to the chord, that means it will bisect the chord. And in that regard, if we will be drawing this OP, we are joining OP, join OP. So OP will be our radius, right? If OP is radius, apply Pythagoras theorem. In triangle POR, it becomes PO square equals to OR square plus RP square. And in that sense, PO becomes equals to 4 square plus 3 square under root, that is equals to 5 centimeter. And we know that OP equals to OT because of radius of circle. So you got your answer. OT will be equals to 5 centimeter. As simple as that. The next concept is, if we have theorem, the second theorem is that if you have two equal chords, let's say this is PQ, this is RS. Okay, so if these are two equal chords, then equal chords are equidistant from the center of the circle. That means if I say, let's say this is O and it is the center of the circle, if we are drawing a perpendicular from here to here and this becomes T and another perpendicular is here, this becomes U. So I can say OT equals to OU. So this is your theorem 2. Third theorem says, if there are two equal chords, let's say this is a chord and this is another chord, okay, and if I am saying PQ equals to RS, if PQ equals to RS, then if we join them through center, if we join it through center, so angle POQ will be equals to angle ROS. Why it will become POQ equals to ROS? Just see, PQ is equals to RS, OR is equals to OQ, and OP is equals to OS just because of radius. OR, OS, OQ, and OP are the radius. So by SSS property, both the triangles are congruent, right? And that's why we'll say that these two triangles are drawing an equal angle at the center of the circle, right? Next theorem says line drawn from center to the tangent is perpendicular at the point of tangency. Okay, at the point of tangency. So by that, what we mean is, if there is a circle and if there is a tangent drawn, this is your circle O. Let's say this is PTQ is a tangent. So OT will be perpendicular to PQ. Right? Fifth theorem says that if there are two tangents drawn on a circle, let's say this is my circle, and there are two tangents that you have joined, so they will make kite, right? Because this is your point of tangency. Let's say this is P, Q, R, S. So SR equals to SQ, radius. S is your center. So SQ and SR are perpendicular. Right now we read that tangents at the point of tangency, radius makes an angle of 90 degree with the tangent, right? So SQ and SR are perpendicular. From here, I can say that PQRS is a kite, PQSR is a kite, right? Next concept is that if you are making any angle, let's say this is a PQ is a chord there, and if you are if it is subtending an angle theta or alpha, this is R. If it is subtending an angle alpha at the circumference of the circle, then at the center it will draw an angle of 2 alpha. So that means any chord makes an angle twice of the angle that it makes on the circumference. Right? Any chord makes an angle twice at the center of the angle that it makes on the circumference of the circle, right? Or in other way, we can say that angle made by any chord at the center is twice the angle made by the same chord on circumference. Same chord on circumference. Right? Next concept is that if there is the seventh concept is that if there is any chord and it is making an angle of, let's say this is alpha at the circumference, then if you are drawing another angle with the same chord, the angle will be same, it will also be alpha. So by that I mean, if this is POQ and R, angle POQ will be equals to angle PRQ. Right? Anywhere if you are drawing an angle of, let's say this is PSQ, it will also be alpha. But angle should be made by the same chord, PQ chord. PQ chord. Okay? Right? Now next concept says, the eighth concept. Right? It says, this is a very important theorem. This is alternate segment theorem. It says, let's say this is a circle, there is a tangent, let's say this is a tangent, and there is another chord that is, let's say this is a chord, it is meeting the tangent at the point, and that, let's say that point of tangency is B, this is D. Okay, so now the angle made by this chord, this angle will be, if I am saying this is, let's say this is A, so angle made by this chord with the tangent, that means this angle DBA will be equals to the angle made by the chord on the opposite part of the circle, that is this angle. That means if I am pointing this as C, so angle DBA will be equals to angle AC. And this is a very important theorem, guys. CAT has asked questions on this particular theorem twice. Now the ninth property says that the diameter makes an angle. Let's say this is your diameter, PQ is the diameter. So diameter makes an angle of 90 degree at the circumference. Okay, so this angle will be 90 degree. Angle POQ will be equals to 90 degree, right? Now the 10th concept is that, let's say if there are 2 seconds intersect each other internally or externally, so by that what I mean is, let's say this is just 1 second, this is another second, okay, and this is P, Q, R, S, O, then PO into OQ will be equals to RO into OS. Right? And similarly for 1 second, and similarly for the external thing, it will be like, and similarly for the external thing, it will be like, 11th will be, if this is a circle, let's say I'm drawing it at an external point. Okay, this is at an external point, and let's say I've joined this like this, join this like this. Again, this will be equals to how much? P, Q, R, S, T. So PQ into QR will be equals to PS into ST. So remember these 10 concepts, guys. We'll be coming very soon with 3 or more 4 4 more concepts on circle, and then we'll have some practice on this concept. If you like this video, please like and subscribe. Let your friends know about us. Thank you so much for joining. Bye bye.